Right, okay, here's a question from last time. We're told a little bit of information. We're told the surface area, and we've got these weird lengths, 2x, y, x, and it's asking us to work out the maximum volume. So let's just have the confidence just to write down what we know. So let's start off, well, to work out volume, it would be 2x times y times x. So that would be 2x squared y. Okay. If I want to work out the area, then what do we got? We got 2x times y, 2x times y, and then we've got plus x times y, and then we're going to have plus as well a 2x times x, so 2x squared. And then everything counts twice, so I'm going to multiply all of that by 2. So if we now think about what a is equal to, if we simplify this, 6xy plus 2x squared. Right, what do we know? We know the surface area is equal to 108. So let's replace that a with 108. There we go. So 6xy plus 2x squared. Right. So let's simplify it a little bit. We could just simply divide everything by 2. That just makes something just slightly easier. Here we go. So, whoops, I forgot to times that by 2, didn't I? There we go. I forgot to multiply that bit by 2, so it should have given me 4 there. So it gives us a 2 there. Okay, so what we're looking to get at this stage is we want to get, I'll just move that up a little bit for you so you can see what I'm doing. We want to get y equals, okay, so we need to get a y equals, and I'm just going to make sure the focus doesn't go out here for us, okay. Right, so we want to get y equals, so let's take away 2x from both sides, okay, and then we're going to divide by 3x, there we go, divide by 3x, and we got y equals, right, okay, so now let's come back over here, and let's rewrite this, but without y in it. We know that y is equal to this bit, so let's go and pop it over here. So we've now got v equals, we've got 2x squared, and then multiply that by 54 minus 2x squared, and that's all divided by 3x. Right, so let's just see if there's anything obvious that we can do. So if we can take out this x just here with one of those ones. So v equals, so we got 2x, got 54, take away 2x squared, and that's all over 3. Right, so again, let's just multiply out this bracket, just tidy it up a little bit, and we're going to end up with 108x over 3, take away 4x cubed over 3. Okay, we're trying to find out the maximum volume, so we need to find out dv over dx. Okay, looks a little bit complicated, but it's not too bad. Okay, so that's just going to be 108 over 3. Take away 3 times 4 divided by 3, 4x squared. So what are we interested in now? We want to know, so we want to know the maximum, so we want to know a turning point. So we need to find out when that's equal to 0. So here we go, 108 over 3, take away 4x squared. When is that bit equal to 0? Right, so let's have a little look, just turn that around so it's a little bit better. There we go. So add 4x squared to both sides, 108 over 3 equals 4x squared, multiply both sides by 3, or rather let's say let's divide by the 4, so then that's going to give us 9 equals x squared, so x must equal plus or minus 3. Now remember, we're after the maximum, so what we should actually do here, which, and this is the bit that a lot of people miss out, yeah, okay, it's not going to be a negative, is it? It's going to be plus 3. But actually, if we want to get the full marks, you should actually remember to find out the second order, okay, because that's going to tell us about maximum and minimum points. So if I just simply write this down, it's minus 8x. If I substitute in the 3, if I put x equals 3 in there, it's going to give me minus 24. Therefore, a max point. So, don't forget at this point, don't forget to, now we've got x equals 3. We need to substitute that back in because we actually want to find out what the maximum volume is. So remember the volume is 2x squared. Just move that back so you can actually see that. There we go. So volume is 2x squared y. So if I go and plug that back into here, you've got to work out y from here. And if you piece all that together, you'll get the volume turns out to be 72. Y is going to end up being 4. And you've got 2 times 9. So that's 18. 18 times 4. So that's going to give us centimetres cubed. Right, there. Right, let's have a quick look at another question. Similar sort of idea. Right, here we go. So, very similar question. Let me just straighten that up for you. There we go. And we're going to have a quick try at this one. So what I would suggest that you do, you might want to pause it for just a minute and have a go at the question, right? But I'm gonna sort of crack on now and see what we end up with. So find the minimum possible surface area. So it's quite similar to the last question. There's a couple of things that are a little bit different. So again, I'm going to write down the area. This time it's told me the volume, hasn't it? So the volume. So it's still 2x, and it's an x and a y. It's just in a different order. So those things are going to be exactly the same as before. So the volume is 2x squared y, and the area, remember, turns out to be 6xy plus 4x squared. This time, though, we happen to know the volume. So we're going to write that in there. So 200 equals 2x squared y. Right, so that might seem sensible maybe to divide both sides by 100. So let's do that. Divide both sides by 2, sorry. What am I talking about? There we go. Remember we want to get y equals. So divide both sides by x squared. There we go. Right, so now we've got y. And then we're going to rewrite this bit over here. So let's go over and do that. So we've got 6x multiplied by 100 over x squared. Multiplied by 100 over x squared. And don't forget we still got plus 4x squared. So the area is equal to that. Remember, we're after the minimum possible surface area, so I'm going to differentiate in a minute. But before we can do that, let's tidy this up. Going to cancel out here, look. So we're going to have 600x to the minus 1. You could write it over x if you prefer. Remember, I'm thinking ahead, thinking, well, I'm going to differentiate, so I'd prefer it to write it like that. Okay, so let's try and use the correct letters in the right order for ourselves. So we've got dA over dx. So that's going to give us minus 600 x to the minus 2 plus 8x. What do I need to do now? I need to find out when this is equal to 0. So let's write this down. So when is over x squared plus 8x, when's that going to be equal to 0? So lots of different ways that you could go about doing this. Let's add this to both sides. That seems like a good idea. So 8x equals 600 over x squared. Multiply both sides by x squared. That becomes an x cubed. 600 divided by 8 is 75. So x equals the cube root of 75. which is 4.22 to 2 decimal places. Okay, if we need to write it like that. What have we got to do at this stage though? Don't forget, we would need the second order. I need to show that this is the minimum. Remember how to do that? Let's take the second order. I'm just doing it over here just because I want to be able to show you on this screen here. So if I do that part there, that's going to give me 1200 over x cubed plus 8. I'm just going to put that in just so you can see that. Sub that into there. Remember, you're just going to cube it, so that's actually going to be 75. So it's going to be 1200 divided by 75 plus 8, and that's going to equal 24. Positive, therefore minimum point. Alright, so we've proved it's a minimum point. Right, great. Find the minimum possible area of the box. So take your 4.22 at this stage, and then all we're going to do is we're going to pop that back up to the top, and we can find out what the minimum possible surface area is. We've got that. Don't forget to do that last bit of the question. I'll let you do that bit. Right, there we go. Okay, so I suggest now that you look at the next couple of examples on the next clip, and again, maybe then going to try a few questions.